Good evening, my name is Kobe Solano.
My name is Noah.
And my name is Lazaro Rodriguez.
And our project covers solar energy. I will be covering a brief history and the development of solar energy. Lazaro will be focusing on modern applications, and Noah will be mentioning the cons and improvements that can be made. As I said, I'll be covering the developmental stages, how solar energy began, the major milestones, which include solar-powered cars and solar-powered aircrafts. Always the need for solar energy. We can see in nature a prime example in plants harvesting the sun's rays in order to photosynthesize, which is essential to human life. In this picture, we see someone utilizing a magnifying glass to focus the sun rays to heat up this tinder and start a fire. However, solar energy as we know it started off with Edmund Becquerel. He's the one who developed the photovoltaic theory. He pretty much came across this theory when he discovered that certain materials, when exposed to light, could produce small amounts of electricity. This led to the development of the photovoltaic cell. Initially, the photovoltaic cells were made of selenium wafers, but they were not very efficient and were not able to produce any electric current or power any electrical equipment. However, an improvement was made by adding a thin layer of gold, which increased the efficiency to 1%. Throughout the years, different designs were able to increase the efficiency to 4%, and a major discovery was made with silicon cells, which increased that 4% to 11%. Technological milestones. We start off with the Vanguard 1, which is the first satellite to utilize cells to power its radios. The Vanguard 1 used 6 cells in its journey, and this became major influence in the use of solar cells in space applications. In addition, we have the Solar Challenger, as seen here. It was the first solar-powered aircraft to use solar cells. It used around 15,000 cells in its journey from Pantwas, France to Manston, England, which was a staggering 163 miles. And it produced around 3.8 kilowatts of power. We also have the Quiet Achiever, as seen here. While it was not the first solar-powered car, it was one of the ones that made a huge impact in the industry. It traveled from Western Australia, from Perth to Sydney along the east coast, and its trek was 2,500 miles. It completed its journey in 20 days, which was 10 days faster than the first gasoline-powered car took to complete the same journey. In this next slide, we have, in modern history, we have the ISS, which uses solar cells, around 33,000 cells, and they are assembled in arrays, which Lazaro will shortly talk about. Here we have a solar wind hybrid. As seen here, you have solar panels, and wind turbines bordering the facility. With that said, Lazaro will talk about modern applications of solar power.
Hello, my name is Lazaro, and I'll be talking about modern applications. But before we begin talking about modern applications, we should definitely look at how photovoltaic cells work. And the reason why we want to see how photovoltaic cells work is because this is a huge fundamental part of how currently we harness solar energy. So a photovoltaic cell is made out of semiconducting material, and basically all that this means is that it is a nice medium for electricity to flow in. And much like in a battery, the cell has a positive and a negative field, and this is what allows to capture the electron to flow in a certain direction to create the energy, or the electricity. So as sunlight or solar energy hits the semiconducting material, electrons are free to flow. The positive and negative field allows for a path to electrons to go through, and then we capture it as electricity. The photovoltaic cells can be aligned to create a module, and then the modules can be put together to create an array. An example of the arrays used in modern history or modern application is the ISS, like Kelby was talking about earlier. And basically what this does when you arrange all these cells and modules together is that it creates higher power or more power. It generates more power. Currently, utilities use this modern technique called concentrating solar power to generate high amounts of energy. And basically here we have 4 different types of plants that do this. How these utility plants work is by reflecting sunlight with mirrors onto a receiver. And the receiver has fluid that heats up. As this fluid heats up, the energy is used to power steam turbines or motors to generate electricity. Right here is an example of a power tower where all the mirrors are located in a circular motion, in a circular fashion, and reflect sunlight onto the receiver in the middle. And basically this is the main sort of differences between all these 4 types of utilities. It's just how the mirrors are arranged and how the receiver is arranged as well in respect to these mirrors. The impact that solar energy has had in the commercial sector and in residential homes in the United States can be seen here. You see that companies have been investing in photovoltaic projects to produce their own solar energy. Currently, there are over 1,110 facilities that have invested in these photovoltaic projects to produce their own energy, which is an increase from 28% from 2013 to 2014. That being said, over the past decade, the amount of companies that have been investing in these projects has been gradually increasing as well. Currently, as of 2014, all these companies combined generated 569 megawatts of power. Right here we have a chart that shows the top 25 companies that have invested in these photovoltaic projects. Just to name a few, we have Walmart, which is a leading company investing in these projects, followed by Kohl's, Costco, and then Apple. We can also look at technology in residential home areas for space heating and cooling. A study shown in 2010 demonstrated that 72% of the consumption of energy in a residential home was due to water heating, space heating, and space cooling. So technology used for this type of aspect in residential home areas will definitely help reduce costs in the long term. And just to name a few positives for solar energy, it is definitely abundant, it is renewable, and sustainable for future generations. Although it is not environmentally friendly entirely because of manufacturing, distribution, and installation processes, it is still much more environmentally friendly than fossil fuels. Lastly, it also helps reduce costs in the long term. Up next will be Noel talking about the cons and improvements of solar energy technology.
Good day, everyone. My name is Noel, and I'll be addressing the cons and improvements of solar energy. Out with the old, in with the new. Solar energy, when compared with its forefathers in the fossil fuel industry, poses a lot of advantages to its consumers as well as the general public. As Lazaro mentioned in the previous slide, some of the advantages are that it's sustainable, environmentally friendly, and it's also abundant. However, despite this perfect picture that we paint of solar energy, there lies a few flaws. The first being immense supply. Because solar energy relies solely on the sun's energy as a source of power, many have questioned its reliability of supply during prolonged overcast conditions or at nighttime. Secondly, we must also consider the efficiency of solar energy. Solar cell panels today are designed to operate in their conversion of sunlight to electricity at best at an efficiency of 20%. Though this number might not be horrible, it shows that there's a lot that can be worked on in its improvement. Thirdly, we must consider the immediate expenses of transition to solar energy. The initial transition costs of solar energy have been recorded to be at least 3 to 6 times higher than that of fossil fuels. This is mainly because of the high level of material purity that's required to operate these solar cell panels. The level of purity is correlated to the efficiency of the flow of the charges. However, these cons are currently being worked on, and when compared to the cons of the fossil fuel industry, are well worth the sacrifice. One of the more recent improvements have been the establishment of a solar system, a solar generation system that can operate at 18 hours a day full capacity without the presence of the sun. This system, called the Gima Solar Power Plant, is located in Spain. It's projected to run for 24 hours a day for most months of the year. The second is the recent developments in nanotechnology are being used to optimize the efficiency of solar cell panels. The contribution of engineers to this process would be in finding ways to fuse these nanocrystal cells into a system that can transmit energy into a circuit. If successful, we're looking at solar cell panels that can run at upwards of 60% efficiency.
With that said, our project covered a brief history of solar energy, modern applications, content improvements that can be made to solar energy. As you can see, there have been various improvements from the humble beginnings of solar energy, and we continue to do so with the advancement of technology. Thank you very much.